So I will talk about a little bit about Zabbix proxies. So, apparently this is a theme today. So about me, this is not really important, you know this already, but you may find my LinkedIn profile and GitHub repository quite useful, especially the GitHub repository. There is some stuff there. And let's dive right in. So most of you would be familiar with this setup. So what we have here, we have a classic Zabbix proxy cluster, which utilizes CoroSync a pacemaker for an active standby solution, right? So we have a load balancer here, although it must not be a load balancer specifically. You can go with keep alive or whatever you want. I'm just using this to, let's say, give you a primer for the next slide, which is awful. So how does it work? Of course, you have the proxy name with hostname proxy with the active and standby. Of course, you have that. What would happen if you had both of those instances active? Most of the time, that would be a configuration error because you do not want that. But what if you wanted that? So this is an alternative approach where you have a cluster of active proxies which all share the same host name. So it is proxy, and they are all active, right? They are all accepting connections. Of course, they're all accessing Zabbix server. So what would be the use case and what are the considerations for this to actually work? So it works only with active proxies because the active proxy will connect to the Zabbix server. With passive, that wouldn't work because you have only one IP. Then it will work only with active items. So passive items are a no-go because you would actually perform a DOS attack on your environment if you did that, unless that is what you want. So, go ahead. Next, the proxy overload protection might not work as expected because you have a proxy queue, and if you have, 3 or more proxies with the same name, that would probably mess something up. So, that might not be good. Also, sticky sessions are required for some types of preprocessing, namely the change and change per second. Because if you have the same host writing to different proxies, then you have different calculations. So you don't want the same item to be processed on the different proxies because that would yield invalid results. And next step, the config cache reload should be synchronized because you want all the proxies to share the same configuration. So that is a challenge. And the last thing is that troubleshooting may be challenging because if you have an error, then pinpointing it might be quite hard. Why? Because you have the same proxy name everywhere. You don't know which host writes to which proxy, so you need to monitor each and every log file separately. Also, you need to monitor the queue, the config cache usage for each proxy, and that may be challenging. So considering that this setup can work under certain conditions, it may be possibly dangerous if you use passive proxies. I and my colleagues consider this to be absolutely barbaric, but also, if you hadn't already, this is your reminder to think about the Roman Empire. So, what are the advantages of such a setup? First, it works. So it was tested with, I think, a couple dozen NVPS. So, for a small environment that worked, and that's something. It is resilient to node failure, because if you have multiple proxies that are doing basically the same, if one is down, then you don't need to actually do anything. The load balancer will just forward the request to another proxy, so that's a plus. And scalability achieved. So basically, you can put this in any environment. So you can go in Kubernetes and have auto-scaling there. You can put it in Azure. You can put it anywhere because it will just work. on the condition that each proxy has its own database, but there's that. Though it might work better with 7.0 than it actually is now. So, it's something. And thank you. That would be all.